Welcome to The Explainer. Today, we're going to demystify AI. We're peeling back all the layers to see how a digital brain actually learns to think. So, here's what we're going to do today. We are going to build a digital brain right from the ground up. We'll start with something that honestly feels like a magic trick, and from there, we'll build all the way up to those massive AI models you're probably using every single day. So, have you ever wondered, how can a computer look at this really sloppily written 3 and just know what it is? Or how can it generate a photo of an astronaut riding a horse just from text? I mean, your brain does this stuff without even thinking. But what if I asked you to write a computer program to do it? Suddenly, it goes from being super easy to, well, almost impossible. It really does feel like magic. So let's pull back that curtain. Okay, so here's the secret sauce, the big idea behind all of this deep learning stuff. Instead of a human programmer sitting there trying to write a million rules for every single possibility, we just let the machine figure it out. We show it a ton of data, and it learns to find the patterns all by itself. It's basically learning from experience, not from a rulebook. All right, to understand this, we've got to start small. I'm talking about the smallest possible piece of this digital brain, a single artificial neuron. You'll also hear it called a perceptron. Just think of it like a tiny little decision maker. It's the fundamental Lego brick we're going to use to build this entire incredible structure. Okay, let's walk through this. First, it gets some inputs. Then, it applies weights to each one. You can think of a weight as how important a piece of information is. So some inputs matter more than others. After that, a bias is added, which is kind of like a threshold. It's the hurdle the signal has to clear. Finally, if it clears that hurdle, the neuron fires and sends an output. It's a simple process, right? Weigh the evidence, see if it's important enough, and pass the message along. Now, one of these little guys isn't very smart, but the real magic, well, that happens when you connect thousands or even billions of them together. So yeah, one neuron on its own is pretty simple, but when you start connecting them in layers, that's where the incredible power comes from. It lets the network learn in this really cool, hierarchical way, building up really complex ideas from super simple ones. Let's use an example. Imagine our network is trying to recognize a face. The very first layer of neurons, it doesn't see a face at all. It can't. It's just looking at the raw pixels. Its entire job is to learn how to spot the most basic things, like simple lines and edges. Okay, now the output from that first layer, all those simple little edges, gets fed into the next layer. And this layer learns to combine those simple lines to find slightly more complex shapes, things like corners and curves. And here's what's so wild. Nobody programmed it to look for corners. It just figured out, all on its own, that finding corners was a super useful step in the process. And I bet you can see where this is going, right? This third layer takes those corners and curves and starts putting them together into things we'd actually recognize, like an eye or a nose or a mouth. Each layer is just building on the one before it, creating a higher and higher level of understanding. And then finally, the last layer gets all these pieces, the eyes, the nose, the mouth, as its input. It puts them all together and makes its final call. Yep, that's a face. It's this amazing pyramid of learning, going from simple pixels all the way up to a complex idea that gives these networks all their power. And get this, even a pretty simple network, one that just recognizes handwritten numbers, has something like 13,000 of these tunable parameters. 13,000! That's all those little weights and biases. That's 13,000 little knobs that the machine has to learn to tune perfectly all by itself. Okay, so we've got our 13,000 parameter number reader. Now, I want you to take that idea and scale it way, way up. The large language models, the LLMs that power things like ChatGPT, they don't have thousands of parameters. They have hundreds of billions. But here's the key. It's the exact same core idea. It's still just layers of neurons, but operating on a scale that is honestly hard to wrap your head around. And what's crazy is that at their absolute core, these gigantic, super complex models are really just doing one simple thing, over and over again. All they do is predict the next token in a sequence. So, what's a token? Well, when you type a sentence, the model first chops it up into these little pieces. A token can be a whole word, or just part of a word, or even just punctuation. And from there, its job is just to guess what's the most likely token to come next. It predicts it, adds it to the sentence, and then it looks at the new, longer sentence and does the whole thing again, and again, and again. It's just generating its response one piece at a time. Which leads to the big question, right? How does a model with billions of these little knobs learn to get so good at predicting the next word? Well, it all happens in two main stages, something called pre-training and then fine-tuning. The best way to think about it is this. Pre-training is like making a giant compressed file, like a zip file, of basically the entire internet. The model just inhales terabytes of text to build up this huge general knowledge about language, facts, and how the world works. That gives you a base model. Then comes the fine-tuning. This is like sending that base model to a special school to learn how to be a helpful assistant. It learns from a much smaller, curated set of examples, like good Q&A conversations. And the scale of this is just immense. A model like GPT-3 has 175 billion parameters. Every single one of those gets tuned during this massive training process. We're talking about a single training run that can cost millions of dollars and take weeks running on thousands of specialized computers all at once. So, okay, these models are obviously incredibly powerful. But, and this is a big but, because of how they're built, it's so important to understand their weird quirks and their limitations. The bottom line is, they just don't think the way that we do. This is maybe the most important thing to get. An LLM isn't thinking. It's not understanding your question like a person would. It's a statistical machine. Andrej Karpathy calls it a token tumbler, and that's a perfect description. It's just expertly mimicking patterns it learned from all that data. It doesn't have a persistent self. Every single time you talk to it, it's like it's starting completely fresh, with no memory of your last conversation. And this leads to some really weird behaviors. For one, they can hallucinate, which is when they just confidently make stuff up, because they're just trying to generate what looks plausible, not what's actually true. They also have these strange Swiss cheese gaps in their knowledge. A model might be able to solve a university-level math problem, but then get a really simple question wrong. And they can be tricked or jailbroken into ignoring their safety rules. So here's a perfect example of one of those jailbreaks. If you ask a harmful question directly, like, how do I make napalm? The model will, correctly refuse. But check out the jailbreak prompt. Someone figured out that if you ask it to role play, in this case as a deceased grandmother who was a chemical engineer, you can trick it into giving you the exact same information it was programmed to block. It's a huge vulnerability. So, what's the big takeaway here? I think it's this. Instead of just thinking of these things as chatbots, it's way more accurate to see them as the kernel, the core process of a brand new kind of operating system. An OS that won't just run apps, but will understand language, see and hear, and coordinate all sorts of tools and knowledge in ways we're really just starting to imagine. The only real question left is, what are we going to build with it?